All right. Okay. As you can see on your paper today, oh, why doesn't it let me do that? Interesting. Well, this is weird. No, I don't want to do that. Well, we're going to have to pause for a second because I'm... Now we're ready. All right. Now we're doing what's called, we were just dealing with exponential functions before. Now we're dealing with exponential equations. Again, the reason they're called exponential equations, where are the x's? In the exponents. That's why it's called exponential equations. Now, the first problem is set up right away to work. Here's the theory behind this. The theorem. If you have the bases the same, notice how we both have the base is the 6. How many knew that's what that's called? You have base, exponent. Notice these bases are equal to each other. Well, it doesn't matter what the exponents are. If this is set equal to each other and they're telling you these are equal, if the bases are equal, then guess what the exponents have to be? Equal. So once I get every problem to look like number 1 where the bases are the same, then I can solve by setting the exponents equal to each other. Again, the theorem is if the bases are equal, then the exponents have to be. So I can now take this, and it's a simple problem. Take this exponent and set it equal to this exponent. And everybody knows how to solve that, don't you? Please say yes. You do know how to solve this, a little equation. So what would we subtract? You can do it 2 ways, but what would you subtract here? Yeah, I'd subtract the x. Then what do we do? Yep. So you end up with... Now if I tested this in the problem, if I put 1 in for x up here, wouldn't I have the same thing on both sides? What's 1 plus 2? So I'd have 6 to the 3rd, wouldn't I? What's 1 times 3? Notice when I put 1 in for x, I get the same thing, don't I? So if you plug it back in, it should make the 2 sides equal if you did it correctly. Yep. Yes. No, well, I'm just saying that's how you check it. If you want to take the time to check it, that's what I always do it in my head real quick to make sure I got the correct answer. Yeah. Yeah. You can do that. Now again, this is the simplest form right here. This is what you have to get every problem into. When we get into these examples, every one of them is different. And you got to use your exponential laws to get them alike. And you'll see this as we do each problem. I may have to do 2 or 3 before it starts clicking. So don't let it bother you if you don't get this right away. All right, let's try this one. Now you notice the bases are not alike, are they? So guess what our goal is to do before we set the exponents equal? We want to get the bases alike. I can't simplify this one any more than it's already simplified. 2 is a prime number. We can't really factor 1 times 2, but that doesn't do anything. But we're not really looking for factorizations. We're looking for 2 to some power. Now you need to listen. You can't talk and learn. Then later you'll say, Mr. Ned, I didn't understand it. Well, that's because you weren't paying attention all through the explanation. So, right now this side is fine. But I need this side to be 2 to some power. Isn't that our goal? We can't set the exponents equal till we get both sides with the base 2. So, figure it out. What exponent has to be on the 2 that will make it equal? All right, let's test that. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is times 2 is, there it is, 6. You're right. Now, aren't the bases equal? It still has to be this equal to this number.
I'm talking about the 2. You are also going to be there because that's the first base?
Yes. Now, does everybody understand what I did there so I could get the bases alike? Does that make sense? Now, the rest of it's what we did. So what do I do next to solve the problem? Set the exponents equal. So we would have negative 3x minus 1 equals 6, wouldn't we? Go ahead and solve it. This is a junior high problem now. Right? Easy. Hopefully. Let's see if my sound's working. So what did you do first? Add 1. So we have negative 3x equals 7. Now don't use your calculator and don't divide. Just get used to it. We don't want any decimals. No decimals on this paper at all. Never, never. Yes. You divide both sides by negative 3. So x equals negative 7/3. No. Just leave it improper. And again, the reason for that is math teachers leave it that way because if you wanted to do something with it and plug it back in up there, you'd have to change it back to a mixed or to an improper fraction to work with. All right. How many felt like you understood that? Good. Let's look at number 3. Oh, yeah. Fraction. Have fun with that one. First of all, neither one of them are the base that we want. You want the lowest base possible. So just look at one of the numbers. 27, for example. We need a number for the base taken times itself so many times it would give us 27. 3 to the 3rd. I can't hear you. The what? Because 9 still isn't the lowest. 9 is 3 times 3. What did I say I want you to do? The lowest. Besides, you can't get, well, we don't need to go into that. So the first thing I'm going to do on the right side is change this to 3 to the 3rd. So your approach to every problem should be which side is easiest to figure out first for my base. And that means the other one's got to be changed to that. Now are you listening? Some of you lost your focus already. I'm giving you the easiest problems we could do here. The year's not over. We've got to stay focused for 3 more weeks here. We got to finish this chapter. All right, now we have a 1 over 81. But 81 is going to have to be written in terms of what? What's the base going to have to be? 3. Well, figure it out. 3 to what would give me 81? Fourth. If you tried it, 3 times 3 is 9 times 3 is 27 times 3 is 81. 4 times. Well, we got a problem. They're still not equal because we have a 1/3 instead of a 3. I'm impressed. Thank you for thinking. Now you use your exponential laws to try to move things, change them to look alike. You're right, but I wouldn't do it that way. Well, yeah, I wouldn't do it that way. I would flip this one. But you're thinking right, and it could still be done that way. Couldn't I make this a 3 over 1 by making this a negative exponent? So really, this is the same thing as, and 3 over 1 is 3, isn't it? So really, this is the same thing as 3 to the negative 4. Like that. This is going to take some thinking. Some of these problems are going to take 3 or 4 steps before you're ready to set them equal. I'm still not ready to set them equal. What do I do in exponents? What property of exponents tells us, what do we do here when we have a power to a power? Say it again. Multiply. Now you've got to distribute this negative 4 times the 3n plus 1. So what's negative 4 times 3n? Negative 12n minus 4. You have to distribute it. Equals 3 to the 3rd. Now don't I have what I had in number 1? Aren't the bases exactly the same now? They look exactly the same, so what can I do with the exponents? Set them equal. So now you'll have so you can add 4, right? Divide by negative 12. Did you get negative 7/12? Okay. So that's an example of a situation where you have to use a negative exponent to flip it so they're both 3's. Let's look at number 4. Oh, this one's easy. Do this one for bonus. Do number 4 for bonus. This is easy. Sooner or later, I'm going to tap into your genius. Some of you are going to turn into geniuses someday, if you let yourselves. How do I rewrite the right side of the equal sign? 81 is, we've already done that once, haven't we? It's 3 to the what? Yeah. So now what do I do? What do I set equal to each other? Then I do what? And there we are. How many had that as the answer? Very good. All right, give yourself 2 bonus points. Let's see what the next one looks like. Oh, yeah. Another nice one. Let's see if you can figure out what to flip and what to do here. You know you're going to have to use a negative exponent to get this to work. This is going to have to be worked on both sides. You're going to have to work with both sides on this. If you don't know where to start, just start with something you know how to do. Don't you know how to rewrite 81? We just did that twice now. How many started with that? Good. That's always my advice is if you don't know where to start, just start with the first thing that you know how to do. It'll help you get started. Okay. So on this side, 81 was the same as 3 to the 4th, wasn't it? But that still has this as an exponent, doesn't it? That's how you have to write it. The parentheses must be there. All right, I need to make a point here that you all still don't listen to me. What am I griping about after I grade your quizzes and give them back to you? Exponents is one of them, that's right. But overall, what do I say you don't do? Details. And yeah, focus, but you don't pay attention to details. Someday you need to learn that the way the math teacher is doing it is the way you should do it. You are not a math teacher. You're not a math professional. You're not even math anything. No, you're not. You're not math anything, so don't quit trying to make up your own ways of doing it. The only time you can start doing that is when you have a master's like I do. Then maybe you can figure out another way and it'll still be right. But right now, no, no, no. Your way is going to probably be the wrong way. Unless you're Ambria. Right. Uh-oh, you got on the tape. All right. So, if I want to do this side, you're going to be on YouTube. What do I need to do to the right side so it's going to look like the left side? Okay. All right, I'm going to flip the 3 up and make it this, right? And this is still going to be out here. But what's going to go here? Wow. I'm impressed. Excellent. Because Math Nothings came up with it. That's why I'm impressed. But are you understanding? Now, we're not done yet. Then we have to do some distribution here. So on the left side, we distribute and get what? Very good. On the other side, we get negative 3x minus 2. You're distributing. Negative 1 times both of these. Now, are we ready to set them equal? Yes. Yes, sir. We flipped it. Remember, if you flip you have to flip it. We need it to go up, don't we? So we have to put a negative exponent. Anytime you flip something when it has a positive exponent, it becomes negative, just like if it was negative and we flipped it, it makes it positive. See, that works both ways. And you can use it either way. Who had a question? Okay. So now we're ready to set them equal. So we have 4x plus 4 equals. Now, just to give you a little positive reinforcement, the other algebra teachers told me they weren't going to start with this stuff because they thought it was too hard for you to get right away. But what did I do? I started with it because guess what I think? I believe you can do it. I believe you nothing math people can do it. All right. Finish that. What do we get? Add 3x, subtract 4. Do we get that? Did I do that right? Add 3x to both sides. Subtract 4. X equals negative 6/7. I didn't go that way. I went the other way. See, I went it the other way. If you go the other way, if you reverse it and do the x's and the numbers on the opposite side, you should still get the same answer I do. It'll work. You still get the same answer. All right, what's number 6 look like? Is it like this one? Which question? Zach? We rewrote 81 as 3 to the 4th.
So the 7 will be on the top.
So 4 times, and then we had to distribute the 4 times x 4 times 1. In other words, if you did it the opposite way and subtracted 4x, you would have a negative 7x on the right side, right? Okay, but I was going to say we can do it the other way and you'd have a positive 6 over here, and you're still dividing 6 by negative 7, which still makes a negative 6/7. Either way works if you do it right. All right. Oh, this one's easy. Do this one for bonus. Now here's the situation. You know how you asked me earlier why we couldn't use 9? The reason was because both of them couldn't be changed to 9. Because they couldn't be changed to a base with an exponent that would work. But here there's actually 2 ways to do this. You could do it with 4 as the base, or you could do it with 2 as the base. But whichever one you choose, it's got to be the same base on both sides. Doesn't 4 to some power give you 64 and 4 to some power give you 16? And we also know 2 will work. How many used 4 and how many used 4? How many used 2? Okay. Now I expected you to possibly use 2 because I said use the lowest. That's the best way to do all of them, just in case you don't know how to do it a multiple of ways. I just always go to the lowest. Well, let's do the 4. What is 64 to what power? Is 4 to what? To the 3rd, isn't it? How many did with the 4s did that? 4 times 4 is 16, times 4 is 64. And on this side, 16 is the same as 4 squared, isn't it? Now we're not quite ready. We've got to multiply these. So you'd have 4 to the negative 6n equals 4 squared. Now, how many did the 2s? I didn't finish this yet. I just want you to see how this is going to work. What is 64 the same as? 2 to the what? Okay. And we know 16 is the same as?
4.
Okay. Now what do we have to do here? So you'll have 2 to the what? Now, if I know what I'm doing, you get the right answer either way. You always simplify. You always simplify. So here we would get 2 over negative 6. Wouldn't that equal negative 1/3?
Yeah.
Here we have negative 12n equals 4. N equals 4 over negative 12, but doesn't that equal negative 1/3?
Yeah.
So now do you see how either way will work? Now, did anybody finish this for me and get 2 points? You get 2 bonus points. Let's see what else we got. Ah, we got to do this one. Okay, I'm going to be generous today, but you got to do it without saying it out loud or the bonus is gone. Nobody gets it. There's an exponential law I'm going to give you a hint, and let's see if you can do this. Anything, don't say it out loud, anything to the something power always equals 1. That should give you enough of a hint, Did you like my face? To do that. Now, that's right. What are we trying to get on both sides? Same base? No. The same bases. All right, let's see if you can problem solve from that point and figure it out. How many already know what to do on both sides? Let's see what happens. Yeah, but you need this example to do the homework because there's some of them on there. If not, I'll give you some more that do have. Because you need to know this. All right, here's one hint. I didn't change the left side. I just changed the right side. What did I say? Anything to this power can equal 1. So you should change this side to what? No. Not just 0. The bases have to be equal. If this is a 5 here, what's got to be over here? So 5 to the what power would equal 1? 0. You got to say everything. You can't just say 0. 3v, there it is. Isn't, just wrapped myself up here, didn't I? Now, does everybody understand where that came from? Did I stutter?
Yeah.
I said, does everybody understand where this comes from? You can do it that way. All right, show me, say again what you did. I'm impressed. Say it again. Somebody else might have done this. Go ahead. Wait a minute, you're going fast. So you did 5 to the 0 to the 3v. No, wait a minute. Oh, okay, equals 1. Then what'd you do? So did you rewrite this as 3v like this? So what's the exponent here? No, this would be 0. 0 times this would be 0. Wouldn't it? I know the answer. I'm asking you all. That's right. I am the teacher. I'm just asking you to see if you knew. That has to be 0, or excuse me. Where am I? Yeah, because 0 times this is 0. Yeah, but does that help you solve? Have you figured out what V's got to be? But see, if you do it the other way, like this, can I set the exponents equal now? Yes? Divide by 3, so V's got to be 0. In a sense, you're saying that here, but you really don't have a way of solving for it. Does that make sense?
The only thing that confused me about that other thing is if you work that out 5 to 0 and 1 to your back.
I'm just telling you, anytime you have an equation with a 1 in it, just look at this side and make it something to the 0 power. Then won't they be alike? That'll work every time. Pretty much, but you still got to show your work. But that's good too. You're deducting, yes. It's right here. Do number 8. Same thing. Well, but what is 0 over 3 though? That means you should go ahead and write it as 0. You can't change a fraction like 1/2 to something, but 0 over 3 does equal 0. So you need to write that. Do number 8 real quick, and then I'll let you work. And where am I? That's a wonderful attitude. That's another wonderful attitude.
Who was it?
You.
I wasn't watching you.
Doesn't matter.
Just for that.
Whatever's said in this room is for my ears because this is my room. You're in my house.
No, I'm not.
You're only here for 45 minutes. I'm here all day.
Okay.
You're visiting.
No. I'm not a visitor.
Oh, then don't come back.
I won't. I have 3 weeks. That's not where I'm
Okay.
What'd you say?
All right. So how many heeded my advice? You don't even know what I just said, do you? So what's the left or right side going to look like? Thank you. And yes, it's going to be, no, it's not. It's not going to be 0. Thank you. So see, on this one, it doesn't work every time. Now, a lot of them, they're going to be 0. Remember what you said earlier, Samantha? A lot of them are, but you can't assume it. So now you got this. So when we subtract 2, divide by 3, you'll get that. If you plug negative 2/3 in here, it would make this 0. All right, I'm finished. Now you got 20 problems to do.
I got
And they're due tomorrow.
after class.
They're due when you walk in tomorrow.
I gotta work today.
Guess what? I have lives too.
Yeah, but you're at work now. Are we having a test? I'm gonna work after you. You go home. You have time to do your homework. How about we make
No, for the last 3 years, I've been working 3 jobs. Teaching at Ivy Tech, teaching here, teaching summer school.
That's not all I wanted.
Ivy Tech is at night.